Okay, so picking up right where we left off, I'm going to go ahead and do this in Desmos and show you how you would do that in Desmos if you don't have a graphing calculator. So I'm going to go into Desmos and I'll just enter in the equation right here. So I've got this y equals x minus 4 over x plus 4. But again, I want to find a table because I want to have some identifiable points. So what I'm going to do here is I'm going to hit edit list. And you see it brings me in here, and right here that creates a table from that function right there. Now, it doesn't give me all of the points that I could possibly get, but it gets me a good start. And so I can see the points right here that it's giving me. And those are a couple that I could plot. I could plot -2, -3, and 0, -1. So it gets me a couple of those points that I wanted from here. But the other way to get the points is just to sit there and keep going through. Let me see here. Yeah, so if you just keep hitting enter, it'll go in that direction. Now, as far as going the other direction for negative, you have to enter that in unless there's some other trick that I'm not aware of. But you can just see here -5, -6, -7. So, I'm doing that and finding all of these. And so that gets me a lot of different points that I could plot as well. Oops, didn't mean to zoom in there. But you can see that that's exactly what it's getting me is these points right here. And that's really exactly the same thing as the graphing calculator. Okay, so that's that problem. Let's try a different one. Let's scroll down to number 4. So right here on number 4, this one's a little bit different. It is not factored. The last one was already in its most simplified form, so this one might not be. So I need to go ahead and factor this out. So first thing I'm going to do is I'm going to go ahead and I've got x plus 5 is my numerator. And I got to figure out the denominator. What multiplies to equal 20 and adds to 9? That's going to be 5 and 4. So this is factored form. And then I'm going to cancel these out. And I'm going to get my simplified form of 1 over x plus 4. So again, these graphs are going to be identical in every way except one of them has a hole, and that is this one here, and one of them does not. So I'm going to go ahead and start figuring out some of these features and going ahead and getting that. So x-intercept. First thing I'm going to do is try and find my x-intercept. Now remember, that's where you take the numerator of your simplified form and set it equal to 0. Well, here my numerator is 1. If I go 1 equals 0, is that a true statement? No, it's not. That cannot happen, so therefore it does not have an x-intercept. Okay, that's fine. So I'm going to come over here, x-intercept, none. All right, vertical asymptote. Remember, that's where we take the denominator of the simplified form and set it equal to 0. Again, the vertical asymptote exists because the entire function becomes undefined there. And that happens when I have a 0 in my denominator. So if you notice at x plus 4, that exists in both the original function as well as my simplified function. So since it's in both of those, it is always going to cause the denominator to be 0 when I have a -4 plugged in for x. So, and I'm getting that because I'm taking that x plus 4 and I'm setting that equal to 0, and that gets me x equals -4. If I plug -4 in here, I get 1 over -4 plus 4, which is 1 over 0. If I plug in -4 over here, I'm going to get 1 over 1 times 0, which again is a problem. So that's why that becomes a vertical asymptote. So I'm going to come over here at x equals -4. So 1, 2, 3, 4 right here. And I've got my vertical asymptote. All right. Let me go ahead and mark that over here on my paper. So we have x equals -4. Horizontal asymptote, Bobobot and Betsy. All right, if I'm looking at that right now, it's bigger on bottom. Numerator up here, the highest degree is 1. Highest degree in the denominator is 2, so therefore the bottom is greater than the numerator, and so that tells me I have an asymptote at y equals 0. Hey, that's why I don't have an x-intercept. Okay, so I'm going to go ahead and do this. Right there. All right, so I have a horizontal asymptote at y equals 0. Okay, holes. Let's see. I already mentioned we had one, and it's because we canceled out here. So here in the problem, if I solve this x plus 5 equals 0, I get x equals -5. So in here, -5 is a problem. If I plug in -5 here, I get 0 over 0 times -1. That's a problem because I have a 0 in my denominator. So that can't happen. But if I come over here and I plug that in, if I plug in a -5 right here, so I have 1 over -5 plus 4, well, that gets me 1 over -1. That's not a problem, is it? That just equals -1. And that's exactly the location of my hole. It's at -5, -1. So I'm going to go -5, -1, and I'm just going to draw a little circle there. That's a hole. There's no part of my graph that exists there, which tells me most likely I have a branch of this graph over here on this side in this little quarter of my graph over here. All right, so I'm going to go ahead and put that hole is at -5, -1. Okay, so let's go ahead and graph it. I'll graph it and find the domain first, or after that. How about that? Okay. So if I'm going to graph this, I need to go ahead and create my table. So again, I'm going to go ahead, put this in Desmos. All right, you can see it right here. Okay. So looks like I can see that vertical asymptote right here at x equals -4. But again, I can't see the hole. I know that there is a hole there at -5, -1, but does it look like it's right there? It looks like there's a graph there. So I do have to know how to find those holes for sure, especially when I'm trying to find things in here. But again, go ahead and graph this, hit the table function over here, and I've got all of this. Okay, so that's a lot of decimals. I don't really like that. It's not what I'm looking for. So, but it's okay. We'll go ahead and do -3. Oop, there's a whole number. -4. -5, -6. Notice that right there. -4, undefined. That was our vertical asymptote. -5, undefined. Isn't that where the hole is? So I got a couple points here. Yeah, they're decimals and we can make the best of it and try and make what we've got here for our point values. So I'm going to do a point at -2 and 0.5. So let's do that. -2 and, I'm sorry, was it positive 0.5 or negative? Okay, positive. Okay, -2 and positive 0.5. And then I also had 0 and 0.25, 0 and 0.25. So again, I can kind of see that that's exactly what's going to be happening here. And you can see that the number just kind of goes right here, -2. -3 goes to 1. So -3 is up here at 1. So I can see that curving starting to happen. So it's going to do this and come up like this. And again, I have a hole here, so I can make a pretty good educated guess that it's going to be going something like that. But I'm going to go ahead and find a couple points to put over there. And so we found -6, -0.5. So that's -4, -5, -6, -0.5. And then there's also -7, -0.3, -7, -0.3, kind of doing that. So you can see I've got that going on right here. So I got this. I got the hole, and I go up to the hole. I don't go through the hole. I go beyond the hole. Okay? And that's how you've got to graph these. Honestly, it's just, you got to make sure that you have some really good identifiable points so that I know that you're actually doing what you should be doing. And then finding the domain and range. When I'm doing that, domain, again, is all of my x values. So if I was to trace my finger along the graph, the only time I would have to pick it up when going side to side is when I'm going from here, hole, that's a pickup. And then I'm come here and I go all the way down to -infinity. But in order to go further to the right, I'd have to go through that vertical asymptote. And I can't do that. And so that's where I also have a break in my domain. So my domain is going to go negative infinity to -5 because of my hole, union, -5 to -4, my vertical asymptote, union, -4 to infinity. Because once we get beyond that -4, once we get beyond that asymptote, it's just a continuous function going this direction. Okay? Range. Again, I can trace along the entire thing if I'm going from bottom to top. And remember, we do it just like a number line. Number lines go from negative infinity to infinity. So I'm going to do my range from a negative infinity to infinity. So it's going to go from the bottom to the top. So the only time I'm going to pick my finger up, if I'm tracing my graph along the graph here, so like if I'm going like this, the only time I'm going to pick it up is at that hole. And then I'm going to go past it, and then I'm going to go here. Well, if I want to get beyond that vertical asymptote, which I can't unless I just skip it, and then I come up here, and I'm going to go continuously that way. So really, the only thing that is preventing me from having that continuous function and being able to not have to pick my finger up when I'm tracing that is the hole or the horizontal asymptote. So that's going to get me my range to be negative infinity to -1 because it's the y value of the range. That's where my hole is located, is in that y value. Okay. And so it's going from that union -1 to 0, because that's my horizontal asymptote, union 0 to infinity. So again, I'm going to trace this along here, and I'm going all the way up, and we're talking about y values. And the y value here is -1. So it's not the x value. This is why the domain and range are not going to be the same, because it's based off of the location of the hole and the location of the vertical or horizontal asymptote. But that gets me my domain, that gets me my range, and I'm good to go at that point. So again, that kind of gets you a couple different examples of things, explaining the whole process if you weren't there from the other day, and it gets you through this. Go ahead and you can finish the rest of the problems on here as your assignment. Not tremendous amount of problems, okay? Let me know if you have any questions.